have a vector. We have next axiomy. We have our vector. We have okay. Let me just derive it here. We have from a diagram. We have CS, and we have cos theta equals to CS. Oh, sorry, small letter CS all over C. Now C is is the vectors at the diagonal. Which is the hypotenuse. And CS is the horizontal. We call it horizontal component. So, and that's equal to, let's make CS. So in the formula we have C cos theta, and likewise the other trigonometry function. Now the CY was C. So therefore CY will give us C sine theta. So we discussed about that, and that's so CX is that's the horizontal component vector. CY is what is vertical components of vector. I'll read that, and also we also talked about the magnitude and direction. Try to just do a recap so that we can get it better. Why, if you feel when you want to go back to it, and you'll be able to get it well. Okay. So we also talk about the magnitude. If you have a vector, you have vector C, and this, and we have its components CS and CY, and we have to get the magnitude of C, vector C. Just give it to the person. Okay. Give it to the as C. Because to using the Pythagoras theorem, we have this CS square plus CY square. That's to get the magnitude of vector C that has two components. That has CY and CX and CY components. So that's what we did last week, and also the direction. For us to get direction, that's when we involve tan function of a trigonometry functions, one of the trigonometry functions. So and that will give us direction, that direction between the two vectors. So we have tan theta equals to CY over CX. Don't forget, CY is the magnitude of vector C along Y axis, and CX is vector C along X direction. And that will give us, for us to get the direction, theta equals to arctan CY all over CS. That's what we did last week, and I'm very sure you're all getting this stuff. And the next one also, we also talked about unit vectors, and I said unit vectors, now vectors whose magnitude is 1 and has no unit, unit vectors, and they describe the position, it is used to indicate or to describe direction in space. Okay, better understanding. Now, okay, unit vector. Unit vector. Unit vector is a vector that has a magnitude of 1. Magnitude of 1 with no units. It has no units. That's what I said yesterday, and it's used to describe direction in space. So, like we have this. Yeah, let's look at this. Let's look at this direction. Now we can call this one y axis, x axis, and the third one is what? Z axis. Z axis. Now to know the direction of these so we have something like this, maybe this one and this. Yes, maybe. Okay, what is diagram? This. Okay. Now, so we can. You have direction in space. You have this one J. You have the high, and we have one K. So, like example, like like I is given to us, and this we call it heart, or call it heart. The symbol called it heart. So this represents a unit vector. It has no units, and it describes what the direction in space. And this most of the time, this one represents what direction in space on the x-axis. Unit vector G describe the direction in a particular vector in the space along y-axis, and the last one we call it, the third one, which is on the z. So this one we call them what? Unit vectors. Unit vectors. They have no units, and the unit is what? The magnitude is what? Is a single one. Now, I said if you want to check, okay, xy plane, I will describe a vector along x, the direction in space. J will be the direction for y in space, and k I'm talking about the xy plane. But we are not talking about in three dimension when we involve x, y, z. So the description of direction, to describe the direction in space, you now have I, J, K, just as what I've written up here. Now here we have a vector C along x-axis. It can be written as this: C x high. If you have vector y, vector C along y, can be represented with cy G. So this Cx is a component of x, and on high is describing its direction in space. Why cy is also a component of vector, of vector c. Cy is a magnitude of vector c along y-axis. So J is not telling us, it's just describing where this cy is in space. And if we now include the third direction, so then we now have something like this. We have this CZK. We have to put this heart on it. Heart. So that is just A. And we now have the full vector. Vector. And we have what's the next page? We have so let's say I have a vector. This vector. And it has okay, a vector in xy plane. In xy plane we have definitely the vector will have its own component cx I unit vector and cy unit vector j, as that's how it's going to give us. Yes, proceed. Okay. Now notice we have two vectors. Okay, vector. Okay, next one is let's say vector c and vector d. Is vector d. Also along the xy plane, have this dxi plus dyj. So it's going to give us. Now, if we involve the third component or the third direction, so we can have something like this. So vector c and vector d will give us this cxi vector unit vector plus cyj in vector plus cz in vector. And vector d, it is a component. We have we have a bs unit vector dy unit vector, as we have dz in vector. So that's all we have. Yeah. I have a question here, or a problem also. Okay, I want us to know how we can get a magnitude and I can get the magnitude of vectors. Now, so there's some problem. So today's work step now. We have a vector. We have problem one for today. So now we start today's work with the with the question, not a problem. Anyway, so the question is given to vectors. Vector A plus 3 and vector b with its component 5 in vector minus 2 0. And the question says find the magnitude of each vector. Sequences so let's do it this way. Express the addition and subtraction of the two vectors. Okay. Solution to this is just simple question. You have a solution. You have, excuse me. Now, solution to this. Now, vector here to is 4. Now, and vector b, we have it this way. We have 5, 0, 0, in vector, to do